Hello, students. I'm going to show you how to use the app that I included in the email I sent you. This is an app for finding the line of best fit, also known as the least squares regression line, and I'll show you why it's called that. Here we've got an empty plot. I like to see the grid, so I'm going to add that. That's this crosshatch thing down here. And I can add points to that to create a scatter plot. So I'm just going to grab a few points out of the bucket here and drag them into position. Just assume that I have a set of data that I'm working from and that I'm not just making this up as I go, which I am. But that's besides the point. No pun intended. Okay, so I've got a set of data here. It looks pretty linear, moderate correlation. In fact, I can look at the correlation here. Actually, that's pretty strong. 0.88 is almost 0.9. So that's pretty much a linear set of data, but not exactly linear. So I'm going to find a line that will fit that data. And I've got one right here. Right now it's got a slope of 0 and a y-intercept of 0. So it doesn't match very well. So let's start by increasing my slope, because obviously this is a positive line. So I'm going to drag this slider up. There you go. And if I move the y-intercept up, it'll come in line with all of this data, and that actually doesn't look too bad. So let's go with that and say that's what I'm looking for. Now, they call this least squares regression. And the idea is that you look at the distance between each of the points and the line, which is our estimate. Those are all the vertical distances. Now, I'd like to make those as small as possible, but some of them are positive, all these ones above the line, some are negative, all the ones below the line. So as we did with standard deviation, we say, well, let's square them, make them all positive, and then calculate an average. So that's what we're doing here. We're looking at the sum of all the areas of these squares as a way of determining, is this the best line I can get? And if we adjust this a little bit, like if I move it up a little bit, you'll see that some of the squares are getting smaller, but that one on the right is getting much bigger. So I think that's probably good. Let's move the slope a little less steep. That seems to just add area to it. So I'm going to go with that. I think that's pretty good. Now, that's called eyeballing it. I'm just looking at it and saying, this looks good to me. Okay, it has the advantage on the app that you can see how the squares get larger or smaller. But let's see what the actual line of best fit is. And I click on best fit line, and there it is. That's actually not too much different from mine. Their y-intercept's a little higher. Their slope, therefore, is a little bit less steep. And we can look at their squared residuals. And that doesn't look any better than mine, I think. Here, these are mine. Oh, well, there are a couple there that they did better than I did, but pretty close. Okay, so that would show you what, first of all, why it's called least squares regression. We're trying to reduce the area of these squares. Okay, this app will give you a chance to play with the line and see how well you can do with it, but it will also give you the equation of the line. So we've got a line here, y equals 0.81x plus 5.05. Okay, so that would be your line of best fit. You can also see the residual squared, or you can ignore that if you don't really care, because you're not going to actually use that. It's just a way of saying, let's make those as small as possible so I know this is a good line. I can also get rid of all these points. I can also move them and see, well, what would happen if I didn't have this point so far down? If I moved it up, see their line of best fit is actually getting closer, and my correlation coefficient is getting higher. The closer the points are to being on a straight line, the closer this correlation coefficient gets to 1 or -1 if it's a negative slope. Okay, so that should pretty much do it. Now, if you're not doing your own graph, if you don't want to do that work, you can always just say, forget it, just give me some data. And we get a totally different set of data here with their line of best fit already in it because I had it checked off. And I get my line here. It says, oh, well, that's my line. I can look at the squared residuals and not much there. Okay, this one obviously is a positive slope for the line and a positive correlation, and pretty strong correlation, for the correlation coefficient R. Okay, feel free to play with that. There's really nothing you can do to harm it. You can always go back, and this is a read undo, so you can take everything out and start over. They have a few different sets of data that you can look at. Gas price per versus time. Now that doesn't look very linear, so that would be a nonlinear correlation, and even the best fit line isn't going to fit it very well. In fact, Look at those squares. What a mess. So some data is just not going to work well for doing linear regression. But if you want to do linear regression, this app is one way that you can look at it fairly easily and quickly. You can also eyeball it, draw in the line you think works, and that usually works pretty well too. Okay, so have fun with this.